Hello, welcome to the Viking Codecast. My name is Erik Trautman. I'm the founder of Viking Code School. Viking Code School is a series of programs, an immersive and a flexible program that allow students anywhere around the world to learn professional web development, and we train people from advanced beginner to job ready. What we have here with our Codecast is a weekly conversation with developers, UX folks, product folks, basically everyone who's in the industry who you as an engineer will or would be working with, and have them come and give you all sorts of interesting wisdom about what life is on the other side of the curtain and how you can get there yourself. So here with us today, we have Matthew, and he is well, I don't even know where to start, but he's a former software engineer who was developing, who went through the development stack, apparently got bored with the development stack, decided to move into product, went back to development, has been in the back end and the front end, has a journey through UX as well, and is currently founder and CEO of Awesome Finance, and has been working in Fintech lately and has all sorts of interesting stuff for us today. So Matthew, thank you for joining us, and first of all, welcome. And I guess my first question for you would really be kind of how did all of this get started? I'm interested to kind of hear how this journey has progressed over the last, what is it, 15 years now?
Yeah, thanks for the introduction, Eric, and thanks for everyone for tuning in. So I didn't, straight out of high school, I didn't have the plan to get into software development. Kind of fell into it, realizing like, hey, I need to do something to make money. And my first experience of programming was in high school, programming a TI-83 calculator, which I'm sure, I don't know what TI calculator is on the market now that people use in high school for their upper division math, but that was sort of in the back of my mind. I had more fun programming my calculator than when I should have been paying attention in class. Almost failed one math class because of that, because I spent so much time actually programming the calculator, writing games and stuff like that. So that's sort of the first tinkering. I sort of taught myself to program on the TI-83. When I was a senior in high school, they had a Visual Basic class, so that was my first sort of formal class or formal education related to programming. It wasn't a very helpful class. The teacher that taught it was actually just a math major that they're like, hey, you know what programming is. So this is back in, I'm going to date myself here, but this was 2002, so 2001, 2002. So then eventually realized I was like, I should probably do something tech related because I like programming. That was kind of cool. I started taking some classes at a private university, a private school called ITT Tech, which some of you may have heard of, which is a big ripoff, a lot of waste of money. They sort of rather than take the approach to private education of like, let's equip you with the best and most efficient tools, they sort of mock or mimic a more formal university environment, but with a lot of filler, as opposed to just like, let's get down and dirty, let's give you the tools you need. That did give me some important tools for software development, but really my big break came when I was working at a Home Depot, and I made a sale, and it was taking a long time. This guy came in and he wanted all sorts of things, so I was like driving forklifts around, pulling stuff off the shelf, and like running every which way, and just trying to give him like the best customer service I could. And at the end of the sale, he shook my hand and he's like, I could use someone like you at my company. You've got a really good attitude. I actually have an electronics company. And he later told me my face lit up like a light bulb. And I was like, oh, yeah, I'm studying. Oops. Hold on, I have a call coming in. Decline that. He said, I have this electronics company, and I could use someone with your attitude. And I was like, wow, this is awesome, right? So he actually hired me to work in shipping and receiving. So it was not a programming gig, but it was a foot in the door, and that's sort of how I got into industry. A few months after that, the general manager came through the shop and was like, you know how to program? Like, why are you putting boxes together and like putting stuff in boxes? You should be like writing programs, right? Like you should be using your skills. So that was sort of my lucky break. That sort of got me. That was my first paid programming gig. Was at Benchmark Media Systems. That same general manager later moved back out to Silicon Valley and was like, dude, if you wanna really advance really quickly and really be on top of your game, you really need to come out to Silicon Valley or come out to California. So he encouraged me to do that. I did do that. I ended up taking a position at Logitech in a business unit that Logitech's a hardware company. Probably a lot of you, if you don't know the name, look on your desk. You may have one of their mice or keyboards sitting on your desk. But I worked on a music product, a networked music product that had a heavy software component to it. Basically got sick of spending a lot of time and sort of like, working long hours and burning the candle at both ends every year to make the Christmas rush to get products on the shelf for Christmas that will be in a landfill in 2 years. So I kind of got burned out on hardware, and it's like, well, what can I do in the pure software field? That's how I got into financial tech, because I figured, well, I want to do something that is not going to end up in a landfill and that's going to help people's lives, or in general make the world a better place, in theory, right? So that's how I got into financial services. Was at Zoom. They do mobile money transfer. So money transfer. So families sending money overseas to their family back home. And then later moved to Boku, B-O-K-U. They do mobile payments. Later went to Monetize. They produce mobile banking software. And then later made the leap to do my own venture.
How did your role evolve though from that initial web development position, or maybe I guess it wasn't necessarily development? You got picked up by the GM who said, you know how to code some stuff for us. How did that role evolve into working in hardware, and what is it like working in software in hardware? I mean, like what does that actually look like? Yeah,
so it's kind of a cool initial role because we had so it was a lot of internal tools initially. So it was working with internal tools, like a sort of homegrown intranet kind of thing built in PHP. This is back in like PHP 2 days maybe. I think PHP 3 had just launched or just shipped. So it was like building internal tools that were useful. Basically like just writing software that makes people's jobs easier and gives executive management access to better information. And then the cool part about it was it was in like in the factory environment, there was this mobile barcode scanner. So it was like this this barcode scanner, and we put a Wi-Fi what do you call them, SD card. It was a Wi-Fi enabled SD card in it. So that connected it up to the network. So I wrote a Java app that ran on this little barcode scanner that connected up to the mothership, which was the intranet software that I wrote. So like you can imagine people building like electronics. They go out into the factory and they like scan a shelf, and they like or they have a bill of materials. So I don't know if people know about when you make electronics, you have a bill of materials. It's like, okay, here's all the 1,000 things that go into an iPhone, right? So you have to go into the factory and scan, and like okay, you need 100,000 resistors of this value. So you just go and you scan it, and blah 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 blah. So it was like putting that all together, and so that was kind of fun. So I got a little bit of the network aspect, the fact that there was a web application there, and then also there was like a little bit of a hardware aspect too. We actually had to, as I remember the project, it's a long time ago now, but we had to, so we found an open source, so it was a Windows barcode scanner, but we didn't want to learn like C# or write C# or whatever. I don't even know if C# existed then, but we wanted to write in Java. So we found an open source virtual machine for Windows C, whatever it was called, Windows CE, something like that. So we had to modify this open source virtual machine to run on this specific hardware, which is pretty hardcore, but it was fun. It was a fun experience. And then the things that got me in the door at Logitech, where it was like a music-related thing, right? And I was working for an audio electronics company. So they're like, oh, this guy knows audio, and he can do software and web development. So just kind of the right fit. Where to probably coming into a pure software role in Silicon Valley, I would probably be way underqualified for that at the time. So it was actually a good interstitial role at Logitech. I had the resume that maybe was weak on the pure software side. Like if I had gone into a whiteboard coding interview and they're like, implement breadth first search, I'd be like, I don't know what those words mean, right? But because I knew, because I could demonstrate, like, hey, I can make web applications, and they're like, oh, this guy knows about audio. That's how I sort of got in.
That's an interesting thing from a lot of people who come from non-traditional backgrounds, which is a lot of the people who are listening to what we're doing now. Is they don't necessarily come from a 4-year CS degree or a CS master's or anything like that, so they're always trying to figure out how to stitch together their background and make that into something that's a little bit more attractive than just like guy off the street learns how to code and finds his way in. What actually worked for you in terms of kind of selling yourself along those lines?
I think so. One big thing getting into Logitech, like I knew their product, so I think it's you can't always do this depending on the business, but it's always like people like to be flattered, like people like to feel like they're important or like people care about them or they're a big deal or whatever. So if you go into a job interview and you know a little bit about the product, like the worst thing you could do when I interview people, the worst thing, especially if it's a later stage interview and they say something like, "So what do you guys do?" You know, like I understand the reality of the job market. Some people just get shopped around by like the same recruiter to like 100 companies. But if you can come in and just be like, "So I understand you have these products, these 3 products, but I'm not clear on like who do you actually sell this product to?" You know, because at the end of the day, if you're interviewing a bunch of companies, it should be a two-way conversation. It's not always, but ideally it should be, right? So if part of that conversation you can be on the other side and demonstrate that you have some rudimentary knowledge of what the company does, and you're trying to understand, you know, as an engineer, you want to understand that side of things. But anyway, not to go too deep in this answer, but yeah. So I think, sorry, what was your question? It was how do you sell yourself with maybe from a non-traditional background? Yeah. So for me, it was I actually knew their product. It was the Squeezebox product. So I actually knew the product. I had used it. So I think that was big. Versus like when the director of engineering came in and he's like, "So tell me about the last project you worked on," and he's like, "Can you draw the architecture on the board for me?" I was like, "Draw on the whiteboard?" Like I don't think I'd ever drawn on a whiteboard in a business setting before. So that was very different, right, coming into Silicon Valley. But the fact that I understood the product, I think that was a big. And people even told me after the fact that was a big selling thing for me. Is like, yeah, he seems like a smart and scrappy guy and can probably figure it out, and he knows the product. So
cool.
Yeah. But yeah, to your point, anytime there's things that are related, like people like to tick boxes, mental boxes. So in terms of when you think about applying for a position, definitely think about mental tick boxes. Like whatever the job description says, like they're looking for those things. They want to make mental ticks of those things. So if they say, you know, Node.js and Angular or Ember and Bootstrap, like the very first 3 things on your resume should be like experience with Angular, Node.js, whatever the other one that I said was, right? Like because then they're gonna mental tick box. Oh, okay, tick tick tick, right? Okay, we should talk to this guy on the phone. Or if it's I don't know, it's a company in the logistics space, right? If you worked at Amazon Fulfillment Center, that can actually play into your favor. You may think, oh, you know, I worked in fulfillment at Amazon Fulfillment Center, like, you know, that's not professional white collar software, but like that can actually work in your favor. You know a lot more than the average just vanilla traditional background software engineer coming in about, because at the end of the day, as a software engineer, understanding the product and customer needs is actually very important, a lot more important than you might think.
Cool. And so you made the transition from supporting hardware to moving into fintech, and what motivated that decision, and then what were the major differences that you found going from one world to the other?
Yeah, it's a great question. So the thing that made me eventually pull the trigger on moving, I was at Logitech just under 3 years, and 2008 crash hit, right? So Logitech like restructured everything. So they stuck half the entire group I was in, they fired. So it was like maybe 100 people in the business unit. Half of them laid off, right? Made redundant in UK terms. So the 50 of us that were left, half of them went to go work on Google TV, the first target hardware version of Google TV. The other half stayed on to work on the product that we actually signed up to work on, and they put me in corporate marketing because they're like, oh, he can build websites, so we'll put him in corporate marketing. And I was like, I don't want to work in corporate marketing. So I was like, I need to go find something else to do. Now's a good time to do something that, you know, the big things for me was like, it's pure software. It's helping the world. It's making the world a better place. I didn't want to do like social networking or consumer apps, like entertainment-related consumer apps. I wanted to do something that like falls in the umbrella. And I'm putting it in quotes because it's always, you have to actually look at under the hood what it's doing, right, to say. But at least as an umbrella idea, it's making the world a better place, or it's helping people. It's providing a valuable, concrete service. So money transfer was like, okay, clearly that's providing a valuable service that people need. Like, you know, the thing I like to say is when it comes to financial services and money transfer, if grandma is sick and she doesn't get the money on time to go to the hospital, like that could be life or death, right? So it's really, really, really important that, you know, if the software crashes and grandma doesn't get her money and has to wait an extra 3 days, like she could die. Like that's sort of a ridiculous extreme example, but that could actually happen, right? So the differences between the sort of software supporting hardware and the pure software, one thing that was really cool, so obviously the cycles were really short. You can do a lot shorter cycles in pure software. Hardware, you have cycles, but there's like a physical thing that needs to be made. So typically in a hardware company, when you get something manufactured, so the software you can iterate fast, but that has to be somewhat in lockstep, or at least compatible. You think about versions of your software have to be compatible with versions of the hardware. And before you get to mass production, you have go through various stages of like pre-production qualification. So there's all these sprints or batches, or I don't know what the right term is. You have various iterations of the hardware. The software somewhat needs to follow that, but then you have some freedom to, you know, do faster cycles. On the pure software cycle, obviously you're not constrained by that. You're only constrained by like how easy it is for us to, you know, scope, size, book, build, test, ship, right? Like how fast can we do that? So in the case of like companies like, you know, Facebook, that could be like 5 times a day or 10 times a day or whatever. Same thing with Google, right? And that's sort of my philosophy as well. Is like keep that batch size really, really small. So that was a big difference. Is the cycle size can be a lot smaller. The other interesting thing was the data-driven nature of it. So hardware you can do like user testing and stuff, but you can't really run as many experiments. Like once it's been designed, you can't really like change the form factor after the fact. It's baked. It's plastic, right, or metal or whatever, or a combination of both. With software, you can run unlimited. Again, your experiments you want to run to change things are only a function of like how much time do you have and cost trade-off of that. So that was another really cool thing. At Zoom, they were very good. This is one thing I picked up at Zoom. They were very good about not necessarily running user experiments, but just looking at the data and figuring out what were the right things to focus on, the right businesses to be on versus not be on, based on the data. And that's now everyone talks about A/B testing or multivariate testing. But at the time, they had a lot of very experienced payments people there. That's why they were very data driven. But that was another big thing. The other thing too, big difference between hardware and I guess this may not be true in all places, but software-wise, I think there's software-focused companies. Like I've heard people say like hardware companies don't do software well or something like that, which maybe is the case. But like there's sort of like when you're at a good software company or in a good software team, there's usually a stack of tools that help you do your job. Like, you know, there's like a pipeline to create, to produce code, to test it, to vet that code in terms of quality and actually does it satisfy the feature requirements, and then moving that into production. So there's this whole pipeline, and generally in software companies, there's in good ones, there's a very nice sort of pipeline that you've set up that's automated, which hardware companies to some extent have that, but I would say it's not as polished. And because like we're all, as software engineers, we're all like lazy, right? So we love to optimize that stuff. So I'd say that's another difference.
What about in terms of the actual development challenges that are faced in each of those cases? I mean, I'd imagine that those are very different. In particular, Fintech has its own challenges, and maybe that's dependent on exactly which portion of the platform you were working on. But I'm very curious to hear that, because I don't think we hear from enough people who are in particular in the Fintech side of things.
Yeah, it's a great question. So, so in the hardware side, oftentimes you're memory constrained or processor constrained, right? You're dealing with small processors, smaller memory footprint. So a lot of times that's a constraint. Or a lot of times, so here's an area where they're similar. In the hardware world, oftentimes you have constraints related to like, oh, we have these whole bunch of devices in production that have this old version that has this thing we have to work around that doesn't, it's constraint because the firmware is baked in with this thing and we can't change that or whatever. Similarly, in the fintech world, a lot of times you're dealing with kludgy, like the older school financial services APIs are very kludgy. Like the way payment cards work is really kind of ghetto. Like it's very, very messy, and like, so you have like the official ISO standard that says one thing, the bank you're working with, their specification, which says a different thing, and then you have the reality, which doesn't match either of those things. So that can be really, really, really challenging. And I'm not exaggerating in the least. That's seriously the way it is across the board. So it's amazing how well the payment card industry works all the time, because under the hood it's really, really messy, payment cards specifically. So that's sort of a similar, it's like an analogous, right, the challenge there. You just have this stuff that's out there in the wild and you have to deal with it. The big challenge, so in terms, and then another analogy is like maybe with hardware you're constrained on memory. You're not constrained at all in memory in fintech, but you end up being challenged memory-wise at scale, right? So in the fintech world, most fintech is a volume business. So you need to, like when I was at Boku, we were doing about, I mean, one point I can remember specifically, 7 transactions a second on average. So that's a very high scale, right? So throughput is an incredibly important, you know, the memory footprint's incredibly important. So if you write a little bit of code, you might not think anything of it to do n squared or n to the m, but when n becomes 1,000,000, or when n becomes 7 a second, that's non-trivial. So that's like a big thing in fintech. The other big thing in fintech, somewhat in hardware and software both. Like hardware is a little bit more steady state, right? You like, it's sort of just, well. So the big thing in fintech is like a lot of times it just can't go down, especially if it's a volume business. Like if you go down, you're losing money. Like you're hemorrhaging money every second that you're down. So that's a big thing. That's true of any business in theory, but there's some businesses where you have a little bit more flex time. But financial tech especially, you know, every moment you're, especially payments, I guess payments specifically, every second you're down, you're losing money. Versus if someone's Squeezebox stops working for an hour, like, oh, they'll be pissed off, they won't be playing music, but then again, you don't have residual revenue from them anyway. So to impact to the business standpoint, like, yeah, it sucks and it's bad, but you know, you're not losing money because of it. It's not like people aren't buying new Squeezeboxes at Best Buy because you're down. Like no one knows. So that's like you know, uptime is a huge thing in terms of challenges in fintech. And the other thing, I guess, you know, so hardware moves quickly in terms of like new models. So oftentimes you start with a green slate every year, every 2 years, or every 6 months in hardware. Fintech is very much like, think about like an old village. Like if you've ever looked at maps of London from the top, and it's like just everything just like sort of like grows sort of organically out, and you end up with this giant city with all these like weird cobblestone streets, and like sometimes it feels like that in when you get to applications at scale. There's going to be potentially hundreds of engineers that have touched the code, hundreds of different integration, you know, dozens of different integration endpoints, external integration endpoints, with all those workarounds that I mentioned, and plus all the features. Like think about all the new features, and then there's going to be legacy features that you support, and then there's probably features that you still support in theory, but maybe don't work, and like so it becomes this sort of inevitably becomes messy in practice, right? And there's always technical debt you're going to be dealing with to fix and sort of, you know, refactor things to make them a little bit better to some extent. So that's a big thing. That's versus like hardware. A lot of times it's, you know, it's greenfield very a lot of the time.
Cool, thank you. I do definitely have more questions, but before we do that, I want to give anyone out there a chance to ask any questions that you have. So for anyone who's in the Hangout, you guys are welcome to just speak up. For anyone who's outside or listening, there's a little app. I think you hit like there's a little icon in the top where you drop it down, and there's a Q&A app, and you can ask questions in that, and we'll see those. So you guys are welcome to ask any questions you want along either of those at any time, and happy to answer them. Before we do that exactly, or feel free to drop them in. I did want to ask one more thing about this particular arc, which was, would you mind actually just talking specifically about one of the projects that you worked on, and kind of what the day-to-day of that was when you were working at those early fintech companies, like Boku or, well, yeah, that's probably a good one.
Sure. Actually, maybe monetize is a better one. It's a little bit easier, more straightforward to explain. So, so if you have a bank, which I'm sure pretty much everyone in the Hangout or listening has, you probably have a iOS or an Android app that you can download for your bank. So the project I worked on, so the U.S. has about 100 medium-sized to large-sized banks. So a good many of them, I'd say in the dozens of them, use this software that I built, built with a team, right? So, so the selling point to banks was like, you have it was like an Ionic or Cordova-based application. So it was like Angular JS running in Cordova on iOS and Android, and I think BlackBerry at one point in time. BlackBerry maybe. So that was the selling point. It's like, hey, banks, you buy this one thing, and you have the same experience across both devices with a few optimizations for each device. So my role changed. So I was sort of in a more senior position, or a more, I would say lead. I don't want to say senior. I mean senior, but a lead position early on in the evolution of the project. So initially, in the first phase, it was a lot of research, right? Like, I came into the company, there was this sort of homegrown hodgepodge of like 4 or 5 different not quite frameworks, but libraries that were being used, and to achieve that. And I was like, hey, you know, like single page applications have come a long way. We should use something like Angular or Ember or similar, and you know, like that will, you know, improve the quality of the product and help us move faster. So initial phase was like I did a lot of research, like building like proof of concepts, like demonstrating like, hey, here's how it could work, showing why should we go with Angular versus Ember, stuff like that. So it's making the case for the management team, like here's why we should go with this tech stack. So it's like research and coding to support that research, and then like a lot of meetings and stuff. So then the phase after that is sort of like, okay, we've pulled the trigger, we've decided, and a lot of that is communication too. So a key part of that is communicating with the team. Like, so some people like change and some people like really embrace it. Other engineers you'll find are just like, oh, I don't know, like I don't know if we should change. Like we've invested a lot in the old way of doing things. So you get a lot of those people. So you have to make sure everyone's bought in, right? And so that is like talking with people and showing them the benefits of why we should do it this new way and why they should learn these new technologies, etc. So it involves more meetings and then meetings of actually like training people, like here's how you use these tools, like here's how it all fits together. And so then you go into a phase of like, okay, let's actually build it. So some of that second phase of like, let's build it. Initially, there's some plumbing you have to put in place. Like, okay, that application was, the idea was different banks could pick or choose different features. So like, Wells Fargo might have, they might have like online bill pay, checking and savings accounts, credit cards, and your mortgage. Bank XYZ might not have a mortgage product. Bank ABC might also have a loyalty and offers program. So we had to have these drop-in sort of modular architecture where banks could pick and choose which things that were in. And then like thinking about logging into your bank, like every bank has a little bit different login flow. Sometimes you show the site key and password, sometimes it's a PIN, sometimes it's this, sometimes it's that. So I had to support like a big matrix of features. So that middle phase, the initial phase of plumbing was like, how do you do that? Like, how do you translate this very complex business requirement into actual Angular code and Angular modules? So in a typical day in that phase 2, it was a lot of like, okay, in theory, like drawing things on whiteboards, here's how it could work, and then actually like going and writing code and like trying to make that work. And then you know obviously the other complexity too is like every bank has a different brand, right? Like the application's not going to look the same, so it's like a completely different color and look and feel for every bank. So all those sort of distilling all those into like, okay, how do we actually make something that's modular, that we can very quickly. So we were like the core engineering team, and then there was a whole separate team. Once they sold it to a bank, that separate team would actually color it, so to speak, would actually brand it for that bank and deliver it to them, like turn on and off all the features. So we had to figure out like, okay, how do we make this easy for that team to do their job, to actually deliver it to the bank in the right configuration with all the right look and feel. So then the third phase, after that was somewhat mature and we had shipped the initial version, then it's like, okay, adding new features, adding new modules. Like, okay, now they want to support passwordless PIN on the first page, or now they want to add this coupons thing. So just adding features and like figuring out how those all fit together.
That sounds monolithic. I mean, massive.
It was a very big project. It was a very big project. And then as a more senior level member of the team, like obviously a lot of my day two involved like code reviews, like helping unblocking if someone gets blocked, like hey, there's this error and I can't figure it out, like pulling a chair next to them and like scratching my head with them and like, oh, I think it might be this, or looking over their shoulder and reviewing their code. And so towards phase 3, I would say it was less active coding and more assisting and enabling.
Cool. Thank you. All right. How about questions? Anyone here have anything? Phil?
Yeah, I got one. I was wondering about how much like security goes into this, and how did you what was the approach to internet security and cryptography? I mean, sure, in financial tech, that's a big issue. So I was curious.
Yes. Yeah, it's a great question. So, so specifically the mobile banking app I mentioned. And I don't know if anyone's here uses Angular or is familiar with Angular. Is it a mix of like, is this like everyone like full stack, or is it like?
We go through Angular. We do Rails on the back and Angular and JavaScript and Angular in the front. Okay,
awesome. So so one thing that's pretty common in when you have, like you mentioned, like security is very important, is request signing. So like the idea is like a REST API. You have some secret, so you have some client, like I'm the client. I have a secret and I sign all my requests with this secret so that the REST API can say, oh, this request was actually from Matthew, not just some man in the middle, right? So one way to do that is to have a key on the device, and then you take, like, for example, if it's like a GET request, very similar thing in Boku actually too. In most like Fintech APIs, you do something like, in general, alphabetize all the GET parameters, take the base URL plus those alphabetized GET parameters plus a non-C value, or like a timestamp, plus the secret that only the client knows in theory, and MD5 hash that, or use some hash of that, and add that on as an extra parameter. So like, hash equals blah. So then the REST API takes all that information and reverse engineers it, because it's a shared secret. So the REST API knows about that secret. So it can say, this request definitely came from Matthew, or anyone who actually had Matthew's secret. So that prevents people from just like sending arbitrary requests. So another use of that is like, I'm calling some financial services API. How do they know that it's coming from my servers and not someone else's servers? So one thing you can do is like whitelist IP addresses. That's pretty secure, but having that signing mechanism is a really common way that's implemented. And then different banks have different flavors of that, but that's in general like that's a pretty common thing that specifically in that mobile application that was definitely used.
Thank you. Other questions?
Oh, sorry. I want to mention. I want to touch on Angular. I'm so sorry. So one cool thing about Angular is it has HTTP interceptors. So you can register like for every outbound request, before you send the request, do something with it, pre-process it. So that was how we implemented that. Was we use Angular's HTTP interceptors. So every outbound request got signed according to this algorithm. And actually there was 4 different flavors of that algorithm depending upon the bank. So based on however the bank was doing it, that version of the algorithm would get tacked on to every request. So sorry, I did want to plug Angular real quick because Angular makes that really easy.
I guess Angular won the Angular versus Ember battle.
Yeah, it seems so. It seems so for sure. I mean,
Well,
people at Google
also with you going to your management when you had that.
Oh, it did. Yes. No.
Yeah.
Absolutely. I just by number of users certainly, Angular is the clear winner there. But yeah, it definitely did.
Cool. Other questions?
Yeah, I've got one. I'm just pretty interested in startups, and I was thinking that I might start one somewhere, way down the line from here. But I was wondering what your biggest challenge in creating Blossom was. Any major hurdles that you had to overcome that weren't obvious up front?
Yeah, that's exactly the next line of questioning I was going to have.
Yeah, it's
Before diving in, do you mind just explaining just a little bit about what Blossom does?
Sure. So Blossom, I'm sure everyone's heard the term crowdfunding, right? So in Indonesia, Indonesia is the world's fourth largest country in the world. It's 250 million people. About 80% of those people don't have bank accounts. So there's something called microfinance, which is basically like little mini community-run banks that serve as financial institutions in places like Indonesia. The problem in Indonesia is there's not enough money. There's plenty of people who are actually qualified to, say, get an investment from a bank to start a small business that can generate income for their family. The problem is there's a lack of money. There's a lack of capital in investor terminology. So what we do is we crowdsource money from places like the US and invest it into profitable microfinance in Indonesia. And our tech platform helps us do that more efficiently, collect all the data, manage all the accounts, all that type of stuff. That's what we do in a nutshell. So, investor in the USA can give us money, and then we help them distribute that to a whole bunch of these, what they're called MFIs or microfinance institutions, and then those guys go and invest in each of them, and goes invest in 10 or 100 or whatever it is businesses, and then those entrepreneurs create some business that generates profits. And those profits are shared with the microfinance institution, essentially the mini bank, and then we get a cut of those profits back, and we pass those back to our investors. So it's essentially a marketplace for microfinance investments.
Cool. And then Morgan, I believe you were asking what were some of the challenges?
Yeah. So what was the biggest challenge in getting that started up and set up?
Yeah, it's a great question. The biggest challenge for any startup is obviously time/money. Like, it's really time, right? Because it's really money, right? Because money can buy time, right? So it's ultimately it's a problem of money. We did get some initial early funding, so that's like a problem for any startup. Once you overcome that, really the biggest. So I don't know if you've read Erik Rice's The Lean Startup, but one thing I really like that he says in that book is the most startups fail not because they didn't have really bright engineers or the best technology. They fail because they're doing something that no one cares about and no one needs or no one wants. So product market fit is really a huge challenge for any startup, as it was for us. We initially started as in the US, and we realized early on that there wasn't a big enough market to support what we were doing, which is why we decided to, after we'd almost run out of money, we decided, okay, let's do this. Let's go to Indonesia and give this a shot. Can we figure out a viable model in Indonesia? Turned out we hit on something really great in Indonesia, but we didn't know. We had a thesis at the time, but we actually had to go to Indonesia and figure it out. So the biggest challenge for us was like, hey, our money's going to run out, and this is not going to work, and we're definitely not going to be able to raise money, more money, because what we're doing in the U.S. is not working, right? So, like, we can A, pack it in, right, and just say, we gave it a shot, didn't work, or B, we can, in terms of product market fit, we can go to a different market and adapt the product to work in that market, and that turned out to be a very good decision for us. So product market fit is really huge, and every company, not just startups, but startups especially struggle with this. And once you think you've achieved product market fit, oftentimes you're not quite there, and it'll take several more iterations before you've actually reached it. So I would say product market fit was the biggest. Other challenges, legal stuff is always, anytime you do financial tech, legal stuff is complex, and by complex I mean expensive. So like no matter how legally complex something is, and then it goes back to money. Everything goes back to money. If you have the money, you can pay someone to figure it out. But lawyers are expensive, right? So it's like, how do you do everything legally and above board, but in the cheapest way possible? Because you don't want to overinvest in something before you know you've achieved product market fit. It's kind of a chicken and the egg. Like, hey, we can't do XYZ because we're not sure. Like, we got to make sure like we're doing everything legally, but to figure that out, we got to pay lawyers hundreds of thousands of dollars, and if we pay lawyers hundreds of thousands of dollars, like we run out of money, and then like that may not even have been the right product to build. So sort of chicken and the egg problem there. But it all goes back to money, because if you have unlimited capital, that's not a problem, right? So hopefully that's a good answer to your question.
How did you solve it?
We kind of, I guess you could say, how did we solve it? Research, really. Just being scrappy and just talking to a lot of people, having coffee with a lot of people. I got on LinkedIn and just like, when I got to Indonesia, I got on LinkedIn and just like anyone who knew about microfinance or Indonesian stuff, like who could speak English or could kind of speak English, I was like, hey, let's grab coffee. Like, so did a lot of research to figure out, what's the regulatory environment here? How can we make this all work? In addition to like product market fit, like what is the right product here? What do people need? What are the challenges? All that stuff. So it was just kind of being scrappy and just like heavily use it. So I can say I'm actually maybe one of the only people where LinkedIn's been very, very helpful for me, because I was able to go to a country where I had no connections whatsoever, literally zero, and actually find useful people, get in touch with useful people, and actually end up launching a product. So
why Indonesia then, if you knew absolutely no one?
We, based on some preliminary research, we knew there was we had a thesis that there was a strong market need there. So we had read some insights that there was microfinance was booming in Indonesia, but was capital constrained. So our thesis was around taking a high-tech approach to capital for microfinance using a Sharia model. So Indonesia's a 90% Muslim country. So a traditional banking model doesn't work, right? You can't do something like a lending club in Indonesia. I mean, you can, but it doesn't work within the religious framework. So our thesis was around if using crowdsourcing with a Sharia-compliant model to solve this capital problem in this massive market, right? And anytime you're doing a startup that's going to be like you want to do something at volume, you need a really massive market. And then you look at, okay, there's other countries beyond that, right? So our thesis was like, hey, we think we can solve this problem of capital constraint in Indonesia, which, based on everything we read, there was a big need for that. So that's why we chose Indonesia. I was also inspired by, I think it was, what's that guy on Shark Tank? O'Leary. Kevin O'Leary, is that his name? The bald guy? Mr. Wonderful on Shark Tank. Anyway, he gave an interview one time I watched, and he said, if I was 22, 23, coming out of college or whatever, graduating some program, he's like, I would not try to focus on developed markets like the U.S. I would get on a plane and I would go to Brazil or I would go to China. That's where the opportunities are. The big opportunities are in Asia, Southeast Asia specifically, and Brazil. He's like, I would just buy a one-way ticket, get on a plane, and go there and figure it out. So I was like, that's what I'm going to do. But then I turned out I couldn't buy a one-way ticket because you actually need a round-trip ticket to get a visa on arrival. So I had to buy a round-trip ticket. But practically the next best thing. It was practically a one-way ticket, right?
Nice. So if I could kind of tie things back to the development side, I mean, up until this point, you've primarily been a developer or an engineer or something very close to the software stack, and so during those iterations, you were working within someone else's vision, product timeline, product roadmap, things like that. How did you find that your understanding, or at least your implementation of the development process, changed when you went from that sort of working in someone else's company to like suddenly you're building your own startup, and you're feeling the pressure of all those extra constraints of like, oh my God, we're running out of money and we have to get this thing built, and all of that.
Oh yeah. Well, for one thing, I realized very quickly I have a very low tolerance for engineers who don't ship. I think you get into even a small to medium-sized company, it's amazing how engineers can sort of exist but not really ship aggressively. So I realized quick early on, I was like, if people aren't shipping code, like they can't stick around. One resource I think is interesting and worth reading. It's published by a company called Notable, or Knote. It's called Ship While You Sleep. So their thesis is like, there's tons of engineers all around the world who are very good and you can hire relatively cheaply. Don't waste time interviewing them. Just like hire them immediately and tell them you'll give them a 20-hour paid trial and just see if they can actually produce software. So it's like, if people can actually produce software and it's like it actually is useful, then it's like, okay, let's keep paying them to do that. Versus like, you spend all this time interviewing these quote unquote rock star engineers who work at these unicorn companies, and then turns out they can't ship code. So yeah, my tolerance for like not shipping code, like certainly like, yeah, hey, we gotta get stuff done. But I guess I had enough startup experience to sort of understand the trade-off of like, yeah, we could like optimize it and do this, but we don't know if this is actually going to be a long-term product. So I sort of was already comfortable with the idea of like, we may need to put in 10 hacks to make it actually work. Something that we can get up to test it. Like, I guess I was already sort of comfortable with that. So, like, an extreme example of this is like, I forget where the story comes from, but like, there's some company had like a feature that they advertised on their website. And they didn't know if anyone actually needed it, but they thought maybe people would need it. So they put it up, and it was like on the product marketing page. They never actually built it until like a year later, a customer was like, hey, like I can't figure out how to use this. And they're like, okay, hold on. So like a month later, they built and shipped the feature, and then told the customer, okay, it's ready for you to use. So that's kind of shady. I wouldn't go that far, but like that's like an extreme example. I wouldn't recommend doing that. But in terms of being responsible for like, okay, hey, we gotta like get stuff out the door, and also taking a low-tech approach. That was the big thing. I had to get more comfortable with taking a low-tech approach or a no-tech approach. It's like in the spirit of lean startup, like sometimes you can do things with low or no tech first to validate that it's even like a need or a user feature. So I guess that even in the product, I guess because when I was doing product management, it was a more medium to large size company. And Boku by that time was at like 80 people, so that's kind of like, that's not super big, but it's not certainly not working in a garage, right? So even then, it's like, going out on my own, I really had to lean in even more to just do more really cheap, like no tech or low tech experiments, I would say.
Cool, thank you. I've got a question from the audience here. What are hidden issues that professional software devs you've mentored over the years that come up for them and surprise you? And then what are the resolving tips that you've found to help them evolve beyond that?
And when it says when he says problems, or he or she says problems, does he mean like problems with the developer, like issues they have, like?
Yeah, I believe so.
Okay, so one, like, I think this is true of like some people just write really ugly code. Like, I don't mean ugly of like it's convoluted, but some people just write messy code, like like they'll have like arguments in a function that aren't used in the signature, or they'll have like they'll declare variables that aren't used anywhere, or they'll like leave off semicolons, and JavaScript is forgiving enough to do semicolon insertion, or they'll sometimes use camel case, sometimes use underscore case, or so like I call that messy code. So a tool that's helped overcome that, and the asterisk here is like people are defensive of their code. So if like you go in and say like, hey dude, like you need to make all things camel case, and it's like, oh okay, well in my old company we use underscore case or whatever. So using tools like JS Hint, for example, or a similar code linting tool or code formatting tool, it solves two problems. So number one, it creates a specification that you can point to and say, this is how we do it at this company. We can change it, but this is how we do it today. If we want to modify it, we can, but it's checked into the version control system. Yeah, great tip. JS Hint is awesome. I totally agree. So it formalizes the specification, and number two, it actually checks and enforces the standards, right? Another great tool that I would say works cotangent with JS Hint is JS Beautify. So JS Beautify does things like, do you put a space between the function and the opening parenthesis of your function declarations? Do you put spaces after commas, like indentation, all that type of stuff? JS Beautify will enforce those standards, but it also you can use it to actually just format the code for you. So if you have engineers and maybe they're good engineers, but they are good developers, but they just write really ugly looking code, that's fine. You just put it in your build system, so the build system enforces it. So you don't have to be the one bringing that. It's like, oh, you checked an ugly code again. And they can just run a single command and it fixes it for you, so you don't have to waste time on that. So that's a good thing. Another thing is sometimes people have great potential, but they don't always, like, sometimes they're very intelligent, they have great potential, but they don't always write code that is in the most straightforward manner, and it's hard to put my finger on what I mean by this, but like I can think of a concrete example that occurred not too long ago where there was a series of methods that were operating on an object that needed to do assign new properties. It was like a middleware stack if you've used Express or something like that. It was like this middleware stack, not Express, but a similar framework. And so it's adding stuff to this object, building up this object, and at the end it's like doing something with it. And they ended up they started with an object, they added something to it, then they created a copy of the object, and then they were using like a promise library, and the promise library they were calling map, which is producing a new object, and it was like it bounced all around. And I was like, dude, why not just you have the original object, just use that. So to me that's very obvious, but sometimes some people, they just get into the nitty-gritty of the code and they sort of like have a little bit of a convoluted thought process. So having code review is a great way to do that. So one great metric I love in software is the WTFs per minute metric. So in general, I like code in general should produce the least number of WTFs per minute. So there's like one time this is another good example. So I had a somewhat junior engineer. He read someplace that instead of doing, what was it? It was like, reverse for loops run faster than, like, decrementing integer runs faster in JavaScript than incrementing an integer. So he wrote a bunch of code with all his for loops like decrementing, and there was like other consequences of that were really kludgy, and it was like a WTF every few seconds. So I was like, no, like that's okay, like you're not going to be that's not going to be your constraint in this case. You're not going to be processor bound because your for loops are incrementing and decrementing. So it's because this is a WTF, the cost to the company of having another engineer try to refactor this code or work with this code or understand it, their time of reading your code and saying WTF and figuring out what's going on far outweighs the cost of the additional, not that it actually would, but in theory, if it was adding more processor cycles or more processor time or memory, in this case, the WTF's cost that vastly outweighed the decremental for loop versus incremental for loop costs.
Nice. Thank you. Is there maybe one more question that we could address here from anyone who's in here?
Yeah, I had a question. Specifically, when you started up, when you started your startup, I was wondering, like, were you like, I'd imagine, like in Blossom when you started up, how was the hiring process like? Like looking for talent. Like, is there a litmus test of what you look for, or was there a process? Like, I know you mentioned like you care, you have low tolerance for people who don't ship. Was there a way for you to kind of tell immediately? Like, what was your process like in finding talent?
Yeah, it's a great question. So, unfortunately, initially, I paid too much attention to what other experts, quote unquote, said about early stage hiring. They were like, oh, it should be more of a cultural fit and blah, blah, blah. And so I found someone who was more interested in what we were doing and the values of the company, like producing like the type of product we were producing. And the early stage hires weren't actually able to ship that great. And then I was turned on to this ship while you sleep methodology. So the methodology for them is like just post a job or like post a rec someplace, figure out what what your capacity is. Like, hire the first 3 people who apply. Like, don't even look at their resume, just hire them and give them a very, very tiny task. Like, here's a page, change the button text from this to this. Or right now the button goes to this page, make it go to that page. Like, really, really like tiny, minuscule tasks. And then have like your stack set up so it's like, we already had a build system and a continuous integration system and all that stuff. Code quality tools like JSHand and JSBeautify. So can they follow instructions, actually write code that does what you want it to do, and get that to move through that development pipeline successfully within a reasonable amount of time? So I did a paid trial of 20 hours. And if they could do that, then I kept them on. If they couldn't do that, then so it's the other term for it, this methodology is hire by firing. So the idea is you make the net really wide, like the funnel is really wide, easy to hire people, and then you just fire a lot of them. And it's nothing against them. It's just like they couldn't achieve the result. So like you're just not going to keep them around. But some of those people will. And the thesis is, my time and the time of the team to interview them is way more expensive than the paying them. Even if let's say they do nothing for 20 hours and twiddle their thumbs and play Xbox for 20 hours. Like, okay, that's still less money than if I had brought them in for 2 days of on-site interviewing and coding test and phone screen and reading their resume and filtering through resumes. I've saved a ton of money by actually just paying them money than spending our money by interviewing. So that's the process we use now, and that's fortunately that's worked very, very well for us. But initially it was. But if it's more of a core team hire, so that's like for general engineers. If it's more of a core team hire, the process is generally like I like to just talk to people for 5 minutes, like say something very generic, like, "Hey, tell me about yourself," just so they're comfortable, because a lot of people get nervous. But really, the only thing I'm looking for there is like, can they speak English and can I understand them, and like, do I not hate them? And then I just do a very simple coding exercise. Like really, really like, you'd be surprised at the number of people who have a resume that looks okay on paper and they can't write a for loop. Like, I literally had one, this is like a week and a half ago, had a guy who looked good on paper, and I was like, okay, we did like a live coding session together. It was very, very simple coding exercise. And he's like, okay, I just need to look up the syntax. I'm like, for what? He's like, oh, for loop. I'm like, you're applying for a JavaScript position, you have JavaScript on your resume, and you don't know how to write a for loop in JavaScript? Like, are you serious? So those kind of things I'm filtering for. And then beyond that, it's if it's like an office here in San Francisco, then, which we don't have at Blossom, but if it was one of those type of companies, generally following the phone screen, bring them in for give them a coding test. So the first is like, can you write code when you have someone looking over your shoulder? And it's like, okay, you have to write it now using only the things in your mind. Then, following that, give them something that they can take away, spend as much time or as little time as they want, with an eye to, you're looking for, do they complete the problem? Do they solve it completely, follow all the instructions, and produce nice, clean code? That's like the coding test. Take that away and do it on your own time. Spend an hour, half an hour doing that, and make it really nice. And then bring them in person for like whiteboarding session. And my approach to whiteboarding coding tests is it shouldn't be a gotcha question like you know already or don't. It should be something that's a little bit open-ended, so it's more problem solving. Like I'm going to tip my hat here, but I like to ask people, implement a web application that has these 3 requirements. So number 1, it's a web page. When I join the web page, it shows the list of IP addresses of everyone else who's currently viewing this page, including mine. Requirement number 2, when someone new opens the web page, their IP address should dynamically appear in the list without a page refresh. And requirement number 3, you can guess, when someone leaves, likewise, their IP address should be removed. 3 simple requirements. It sounds very simple, but it's actually it's more complex than you might think. And I like it because it's open-ended. It covers full stack. I tell them you can use any technology. You're the CTO. You decide, but here's our thing. And then at the end, I say, okay, and now we're successful and we have 1 million people currently viewing. How would this change your design? If we get to that, if we get that time. So that's what I like to ask in person. I think those type of questions are better than like implement breadth first search using a red marker only. Green markers are not allowed.
Cool. Thank you so much.
Yeah, my pleasure.
Thank you. So I want to be conscious of your time, and we, of course, have managed to pack a whole lot in here, but I think we're out of ours. Matthew, thank you so much for talking with us. It feels like we've just gotten started. If anyone is interested in continuing the conversation, how could they reach out to you on social media or anything like that?
So on Twitter, I'm Oh By The Way. You can reach me on Twitter, Oh By The Way, and then can follow up from there. Great.
All right. Well, thank you to everyone who's participating. Thank you again, Matthew, for taking part. For everyone else, this is the Viking Codecast signing off for this week, and we'll see you guys next week. So take care.
Thanks, Eric. Thanks, everyone. Bye-bye. Cheers.
Bye.
Thanks.